let everybody in. And so welcome everybody to the Met4Tech Roadmaps launch webinar. I hope you're going to enjoy the next 90 minutes here. So we have what we call the beta versions of our roadmaps to show you, and we hope you're going to have a look and enjoy reading them and make us some feedback. So on the call this afternoon, we have lots of you who've been really helpful over the time of Met4Tech, and this is our last ask of you, is to make some feedback and on these last products of the Met4Tech Centre. So we are recording, as you will have seen or heard, so I hope that's all right with everybody. We're on for 90 minutes here. We've suggested actually on this one today that you keep your cameras off, and then when the panel members come on, they'll have their cameras on so you can see who it is that's talking. And I hope if we don't talk too long ourselves, we'll have plenty of time for some nice discussion and Q&A. And we're asking you to put the questions in the chat first of all, but then we can bring you on camera and unmute you if you'd like to have that discussion in person as we go along. So hopefully that will work out fine. So my name is Frances Wall, and I had the pleasure of being the principal investigator, helping to convene and bring together our team on Met4Tech during the four years and 3 months of the programme. And before we get any further into this seminar, let me do a big thank you to Chris Watson and Carol Pettit, who've brought us together on the webinar this afternoon, and who've been doing a lot of work to actually make our roadmaps appear in the interactive Folion, it's called, form. So it's a proprietary online reading system, which is how we've produced the roadmap. So hopefully they're a bit more lively than just seeing a PDF of them. Right, so I'm going to start just with a few words then about the NICER programme and Met4Tech to introduce us this afternoon. And then after that, we'll go into a panel discussion on the rare earth magnet materials roadmap from Met4Tech. And then we'll go into another panel discussion on the lithium-ion battery materials roadmap. And then we'll have some time for general Q&As at the end. And I think, I can't click the chat here, but I think if she hasn't already, any second now, Carol will put the links to the roadmap. Oh, hey, I see the magnet one is there. That's in the chat. You can find the link. So you can click on that and while we're talking, your cameras are off. So do have a click around and have a look and see how you get on with the navigations, and welcome to ask any questions. Right, if I could have the next slide, please. And if your question is, I can't find it or something, do just put that in the chat too, and obviously we'll try and help out with that. That's exactly the sort of things that we need. Right, okay, next slide, please, Chris. And here we go. Right, so this then, Met4Tech was part of the big NICER programme, which was a huge £30 million investment from UK Research and Innovation in collaboration with DEFRA to actually really get some good circular economy research going across 5 centres. We all did a different flow. Then we were coordinated by the CE Hub. And this afternoon, we're the blue icon there, Met4Tech, and we did the technology metals. So all the real specialist metals that we don't need in such large quantities, but really make lots of high tech and all our clean tech, green economy things basically work. And so we had a long list of things that we were looking at in Met4Tech. If I could have the next slide, please, Chris. Just to say, well, the slide's changing, you can see on the C, if you go to the CE Hub, that's a very good place to start to see what was done in NICER overall, because they've gathered the materials together there, and then you can go to any of the centres. So this is who we are in Met4Tech. So it's a consortium of the universities that you see on the left-hand side. So the British Geological Survey, together with the universities of Birmingham, Exeter, Camborne School of Mines and the Business School, and Renewable Energy, Manchester and Leicester and Aston University. And we organised the centre into research in 4 themes. And so we had the data theme was number 1, and then we did research on the primary raw materials and taking a circular economy view of that in theme 2. We did the chemistry and material science work in theme 3, and then we brought these together with regulatory and social science, policy and governance, and environmental and LCA cross-cutting themes into a theme 4. And this roadmap that we're talking about today was one of the outputs that we wanted to try and bring everybody together across the project to look at what were the outcomes from the work in Met4Tech, and of course talking very much to our project partners and wider stakeholders. And I suppose our outcomes are really looking at what the tech metals circular economy should be. So we know that we need to bring a lot more of these metals into circulation if we want to build the things that we need for the energy transition. But of course, as we do that, we don't want them simply to come into the old style linear economy, which is very wasteful. We want to be able to reduce the carbon footprint and get much cleverer at keeping materials, both for environmental reasons and for straightforward security of supply reasons, of course. And for that, we really need a new circular economy. And when we say circular economy, we really do mean all the way from exploration, geological exploration, right at the very beginning, through all the phases of manufacturing, use, reuse, and finally catching things in the loop of last resort in recycling. If I could have the next slide, please, Chris. So there were lots of things happening in Met4Tech, and many things went towards making the roadmap. There were lots of the work, of course, has come to fruition as academic papers. But really what we're talking about this afternoon, I think, is where we've tried to translate the results into a form that professionals from lots of different disciplines can read, that we hope might be useful when people are thinking about future policy or future industry directions. And on the right-hand side of that slide, we've got some of the outputs from Met4Tech. And of course, the website is there. I think we've got a picture of that in a minute showing where the outputs are, how you can get to them. It's just met4tech.org. We've got the academic publications, but we've also done along the way some policy briefs, some case studies that we hope are really useful for people to understand some good circular economy interventions and business models that our partners have been doing. We've made some methods and models like the agent-based model. The chemists and material scientists have created a toolbox to show some of the ways that you can get much better at manufacturing and recycling. We've got a museum exhibit, which is at the Eden project at the moment, and they have about 500,000 visitors every year. So we hope there's a few people thinking about circular economy of tech metals as they visit Eden. And then we've got a massive open online course, which will be coming out probably in the next couple of weeks. And so that'll be the Tech Metals for a Green Future, updated with more circular economy in it, and that'll be out very soon. But this afternoon, then, let me come back. This is all about the roadmap and our interactive online reports for the road mapping. What should we do from now onwards, really, to have a good circular economy of tech metals? If I could have the next slide, please, Chris. Okay, so here is a screenshot, as I said, of the met4tech.org website. And if you just click on the About, so that should be quite straightforward, click on the About page, and then you'll see all these green boxes which have the outputs from Met4Tech. And in orange and red, when you've finished road testing our roadmaps in the beta version here, then we'll load up the final versions there. And Chris is just pointing to that, or Carol, whoever's on the end of the slides here, is just pointing to them. So that's where you'll be able to find them. So met4tech.org/about/ and you'll see those. And if you want to look for the academic papers, then the big blue arrow there points to resources. As we can catch all our researchers in Met4Tech and the papers that we're writing when they're produced, then we're putting them onto the resources there. If I could have the next slide, please. Right. So, okay. So I've said the word roadmap quite a few times already. So what is a roadmap? Well, our social sciences team led the work with the stakeholders, and they've actually thought about and published a paper, which papers are just going through. I think one of them will be out very shortly, thinking about the road mapping process and what we did and how it works. And also colleagues in the hub have written a big paper looking at about 200 or something roadmaps to talk about what a roadmap is. And so a roadmap should have some kind of like vision about where it is that you actually want to be going and knowledge of where it is that you are at the moment. And then you talk about the actions and strategy that you need to move from your current state to the target state. And usually implied is some kind of time horizon or time steps or steps that you need to take at milestones along the route. And it's important actually to outline measurable targets in a roadmap. And I thought this is interesting every time I look at this slide, because we're going to talk about the challenges in a minute. And I would say making quantitative targets that are in any way meaningful is actually quite a challenge here. So maybe something to talk about, because these circular economies or economies, even the linear part of it, doesn't exist yet. So it's very hard to be anywhere near right with any models or quantitative things that we produce. But nevertheless, we've had a go in some ways we can discuss. And something that came out of some pretty Mahanti and Frank Boone's work is that the process of producing a roadmap is probably, as useful, and they said even potentially more important than the final roadmap. I think that was a finding from the hub as well. And so that we certainly have been doing. And so I hope we've given some useful insights, not only to ourselves as the academics, but to all our kind stakeholders and project partners who joined us for the road mapping activities. If I could have the next slide, please. So hopefully while I've been talking, you might have clicked on the folion. Oh, I should just say before I go to the folion, here is a timeline to show that we did actually do some activities. And thank you very much to everyone who took part, as I've just said, in deep dives and constructor workshops and things that we had both for battery materials and for the rare earth element work along the way through the Met4Tech program. Next slide, please, Chris. Right, so here we are. Here's the rare earth one, and I think you've probably been clicking on that then and having a look at that. So just dive in, and you've got the menu along the top, and then you can click on those, and then you can go downwards to read each page or across. And we did this as an FAQ, so there is actually a series of short academic papers which is in quite early stages of preparation. And so for this product, we wanted to do quite a high level take on it, and we sat down and brainstormed some of the questions that we were being asked and then tried to give them the answers. So that's the way that this is set up when you have a look for it. Okay, and next slide, please. And then you can go the same for the battery materials. The battery materials one we did over a longer period of time, and we tried to bring together the results of a number of stakeholder workshops and the results from the different teams in Met4Tech on that one. That turned into a bit of a gigantic project, trying to distill it into what we've got here. And so you've got what you see on the screen, and again the menu across the top to look at this afternoon and see what you think, and if you agree or disagree with any of the findings and insights and recommendations. And if I could have the next slide, please. What we have in there as we went along, we've created a series of narrative. Oh, sorry, if you could go back to the big snaily thing, right? The narrative highlights. So there are 10 PDFs that will pop out of that folion. I think they're not there in the designer's version that we're looking at this afternoon. You'll see pink links, and that'll be to these highlights, and each one of those is about 1,000 words to dive deeper into some of the topics that are important in the lithium-ion battery roadmap system. So start at the beginning. Up there talks about the importance of even doing circular economy thinking in exploration and then mining. Take the bus, for example, deals with should we be swapping to public transport, and how will that help the battery materials demand. The cars that we make are not the cars that we drive in the UK. We didn't have to do any research apart from reading the Society of Motor Manufacturers and Traders statistics to see this really important point, that 80% of the cars we make here go off abroad, and 80% of the cars we drive more or less are coming in from abroad. And that's really important. There's no nice closed circular economy in the UK. I think CE tends to make us think more locally, perhaps. You might talk about that, but this is a very international world, isn't it? And then we dive a bit more into resources as a service and the power of EPR, and really talk a lot about the different kinds of recycling going all the way through to remanufacturing. And I'm sure we'll talk about missing the midstream and changing battery chemistries this afternoon. You'll see that in the folio as well. Right. Okay, I think that's time for me to finish my introduction. I hope that's been useful. If we could go to the next slide, please, Chris. Then we come now to the first of our panel discussions. So you see the panelists on there. So if Rod, and I'd like to welcome Rod Eggert especially, so our overseas guest from the Colorado School of Mines, and he was online at 6:30 in the morning to join us today. So you're very welcome, Rod. Thank you very much. And Rod's been chairing our advisory board for Met4Tech, so he'll come with the overseas view of rare earths. And then we have from Met4Tech our very own Bob Lee, Markus, Zils, Petavratzi, and I'll just keep my camera on to join the panel in case of questions that come my way as well. And it's my pleasure now to hand over the chair to Matthew Reeves from Innovate UK, who has been working, as you may well know, on the Climates programme, which is the circular critical minerals supply chain programme, helping innovation in the UK so far towards getting a good rare earth circular economy. And so he's going to take the chair for this rare earth magnet materials panel discussion. Matthew, welcome.
Thanks very much, Francis. Good afternoon, everyone. Yes, so I'm Matthew Reeves. I'm from Innovate UK, as Francis said. I've been working on the Circular Critical Materials Supply Chains programme for the last couple of years, which was a £15 million investment by Innovate UK into the rare earth supply chain. And now we're looking to build on that actually going forward. Trying to get some more money together and do a bigger program to cover more of the critical minerals. So it's a really good time to be having this kind of discussion. So thanks for the panelists for turning on the videos. So I'd like to start. So as everybody is potentially having a look at the roadmap in the background to the webinar, I want to start by asking what some of the key insights are that are contained within the roadmap that would be really good to highlight first thing off. So I don't know if I want to go back to you, Francis, first, and then I can go to some of the other panelists.
Yes, okay, right. So I think we should go to Markus in a second to talk on the rare earth magnet, about the part of the circular economy that's pretty much missing altogether. So I think we're fortunate in the UK. We have 2 companies ramping up with recycling, but what about all the other circular economy interventions? And I think in rare earths they're just exactly missing. And I think that's the first really thing you notice right back at the beginning. Markus drew us a circular economy for the rare earths and just put what he calls pain points. So we've picked up that terminology from Met4Tech. Is the pain point is all the things that either aren't there at all or that don't work if you wanted a really full good circular economy of rare earths. And I guess this is, and then a point I was thinking about is that I'm not sure we emphasize enough is, of course, we need to bring more primary supply in to a circular economy. And it's interesting how I probably could have put the same minds and written the same thing 10 years ago as we are today. So little extra supply has come online outside of China. So the same challenges are there. And I think we could talk about what we can do in the UK. And the other challenge that we've certainly seen where we've been working with stakeholders in Met4Tech is the lack of supply chain transparency for rare earths. So I would say that's the other thing that really needs fixing as fast as possible, because that's needed straightforward for responsible sourcing. And it's absolutely essential if you're going to do clever things with circular economy and recycling, is to know what it is that you're actually doing. What is the material? What is the magnet? So that would be my things.
Thanks, Francis. Over to you, Markus.
Yeah, thank you, Matthew. And I think I have three key insights. There are many sort of observations, but the first one is that rare earth is the magical dust. So it's a very small quantity embedded in many sort of complicated structures where you have sort of in vehicles, wind turbines, computer disks. They form an essential service, but they are embedded in components, subcomponents, and then into the ensemble. And a lot of the collection and separation is very much focused on the larger feed streams. Sort of you smelter out the larger components. So it is very, very important to think through how do you actually get the magical dust back. And I think that's my second observation. When we looked into the capabilities that you require for this, it starts with being able to intercept that at a local level. A lot of these streams leave the country today. And the second thing is that you need to have the capabilities to extract the component and the raw materials. And we were very fortunate that in thematic area 3 and also some very sort of leading techniques are being developed in UK, but that requires sort of to get access to much larger scale to be economically viable. I think that's sort of my second observation. And the third thing is that circular economy needs also to look into the use phase. Francis already mentioned sort of taking the bus. The cars we make are not the cars we drive. It's very much around the intensification and prolongation of use, which have sort of, at the short term, the most immediate impact to remedy the necessity for increased imports. And I think the technology that we're looking into right now, they will build up stock very quickly over time. But for the foreseeable future, having sort of reliable, responsible supply of raw materials components is really essential. So there are many more observations, but these three sort of really stick out for me from the work that we have been able to do across the value chain until now.
Yeah. Would anyone else like to comment on that before we move on?
Sure.
Evie?
Yeah, so I'm trying to find the audio button. Okay. Hello, everyone, from me as well. Just a couple more things on what Markus said from the findings we had within Met4Tech. And I think the first thing I would like to highlight is that our modeling work and our understanding of the supply chain has been actually come with some quite profound results. So the first one is that if we're smart enough, if we build the reverse supply chain early enough, then we're likely to have enough material coming through secondary sources to satisfy our needs for demand in the future. Obviously, that needs quite a lot of work. So we need to look at how we build up this sort of reverse supply chain and how the different actors, the reverse supply chain, which at the moment they seem to be quite disconnected, they actually integrate and work together. Because that's quite a huge task. So you need to build up this sort of supply chain that's missing at the moment. And finally, I would like also to highlight one big thing that even if we build up, like recycling capability, this is not enough. We are missing a huge key stage in the value chain, that's the magnet manufacturing. So we need to make sure that somehow along the lines, this is coming through in the UK quite rapidly, because otherwise, whether that's primary supply or secondary supply, the magnet manufacturing is not in the UK. So material is likely to leave the country to go back to China for manufacturing and be imported again as permanent magnets. So that's my
no, I think that's a really good point, and that's something that we've seen as well through our work, and are looking to support that magnet manufacturing base to establish itself and expand itself in the UK to fill that gap. So thanks for that. I think this leads us quite well on to the next question I wanted to kind of raise. So when we were thinking about creating the circular economy that we all want to see, there's going to be a need for lots of stakeholders to change their behaviors, whether that's consumers, whether that's manufacturers, whether it's the government through policy interventions and things like that. So what type of things do we think that need to change in terms of behavior in order to realize the circular economy? So I don't know who would like to come in on that first? Bob, do you have any comments on that?
Thank you. I can. We committed to doing road mapping as part of our grant proposal. And then, of course, it seemed a stretch, at least, to try and roadmap the whole of the critical materials that we were interested in. And therefore, we ended up road mapping two, if you like, product lines, the lead batteries, which we'll talk about, and rare earth magnets. And I think rare earth magnets is an interesting choice. I think we hit upon it partly because of the ubiquity of rare earths. Just the sheer amount of uses to which we put rare earth magnets in a wide variety of products. And it's a great subject to look at from a road mapping point of view, because actually, and this has already been covered, although we have made some start in the UK, there's still an awful lot of infrastructure missing. But for me, one of the interesting things, and you referred to this in the question, is, when we talk about stakeholders, we're not just talking about a consumer population. We are actually talking about a lot of product that's in industrial usage. And I say that as a lawyer, because a lot of the regulation that we have in terms of extended producer responsibility and so on is often directed largely at consumer applications. So if we go and look at the WEEE directive, for example, that largely covers waste consumer electronics. And so for us, I think one important thing is to begin to think about industrial products. I think there's always been an assumption a little bit at a regulatory level that stuff that is in the hands of industry will somehow be stewarded. But I do think we're now at the point where we have to ensure that that's the case. And therefore, in terms of beginning to change behavior, there are a whole number of things. But one of the most important things is simply awareness. Is simply awareness of the value of this material. Some transparent information as to where it is and what it is within products, and some rethinking actually on the social costs, the social and environmental costs of primary material extraction, as opposed to what Evie's just been talking about, and that is the possibility that secondary material resource could actually provide us with what we need.
Yeah. And Rod, would you like to comment on, and maybe comment from your point of view, whether that kind of maps onto your experience in the United States, or how this kind of factors in more globally? Oh, you're on
mute. Certainly behavior is very important. I'm an economist, so I immediately think about the role that incentives play, and I immediately think of the question, what do markets by themselves get wrong that need to be corrected to encourage greater circularity? And so to me, a key issue is not just government and public policy need to be involved, but there needs to be thoughtful consideration of better and poorer ways of using public policy to alter behavior. And whether it's things like extended producer responsibility, which puts it more in the producer's hands, or whether there's something about the pricing of the products that consumers face. We need to be thoughtful about the role that public policy has to play. And in my mind, clearly, public policy needs to be more involved than it has till now in this world of circular economy.
And what do you think the best kind of public policy interventions can be? Is it around regulating the use of the materials, or is it banning the export of end of life stuff, or what's the best policy levers that can be used here?
Again, I'm an economist, and so I tend to favor price signals that that face consumers or producers. I do think extended producer responsibility rules places the responsibility on the manufacturers, who are probably in a better position to think about the best ways and can trade off the refurbishing, remanufacturing, reusing, recycling trade-offs, because those are all quite different circles. And I don't think that I, as a customer, am very well positioned to have an opinion about that. And there's been a lot of work focused on recycling over the last decade, but I think, as Francis said earlier, much less on the other circles in the circular economy diagram.
Yeah. Thanks very much for that. So I think I can move on to one of my next questions. So I think in terms of the roadmap itself, there's a few things in there about what we want to see, what we need to have by 2050 in order to realize it. But just to think about what's realistic. So if not everything in there is going to actually happen, where do we think the realistic gains are to be made in the roadmap? Can I come back to you, Francis, for that first?
Yes, now that is a difficult question, is it not, Matthew? And
Yes.
2050 is a very important year, isn't it? I was really interested by the BGS modelling that said, we might be able to supply a lot of the UK demand for rare earths in the 2040s already from recycling, or in some way reusing what we've already got. And I think in the UK we do have a couple of companies ramping up with recycling. And so then if we watch very carefully and try and make sure that some of that will actually come in to the UK and get those companies going, maybe that kind of timeline will be a possible one. And when I say watching very carefully, I mean, I have in my mind this sort of thing that you could imagine wind turbines being towed in to their position in whichever sea it is around the UK, and then towed back out again at the end of life and never coming anywhere near the UK. And of course, this is a real big thing with rare earths. The amount in your mobile phone is something like 0.07 grams, and then we go up to kilograms in the direct drive motors and electric cars, and then we go up to the tons in wind turbines. So if you really want to be part of that industry, I think we've got to be accessing these larger amounts of the rare earths. So I think that's important. And I think we didn't say very much, I don't think, about the timeline on primary supply. And I think that's very much a matter of investment. So we do have companies who are registered here on the stock exchange, people who live here and who have deposits abroad, and they're developing them, but they're just at the whim of the stock market investors to take them to the next stage each time. And at the moment, those stock market investors, I'm afraid, are investing in gold, not in rare earths, maybe some copper, but they're just not looking at these small technology metal markets. They don't understand them still, and they're too risky, I suppose. And so it's kind of breaking that problem, that challenge, that chain, with getting some investors to go and invest, and maybe helping with that for our overseas supply line, so they come on as well. And then
do you think that's realistic? Do you think that's realistic that we could do something about that?
Well, I think yes, and I think didn't we change? You know more about this than me, but I think we changed one of the laws, so that one of the rules on on loans or lending from the UK to projects which are outside of the UK boundary. And so I think looking at those kind of things about how we can unstick projects is it certainly is realistic. I know from my geological background that the rare earth minerals are there and we can process them. And the trick is, can we unstick the economics around them? Yeah.
And Evie, I don't know if you want to come in here as well, because I know you've been doing a lot around the foresight studies for the Minerals Intelligence Centre, about how some of these things we want to achieve, highlighted in this roadmap, kind of align with what you've seen from the foresighting.
Yeah, I think I will echo what Francis has been said. I think there is great potential in end of life, but we have to be, have to change the way we operate at the moment. And I'm saying that because there is not much incentive at present to actually get access to these materials. Like if you look at policy, right? We've spoken about policy in your previous question, but if you look at policy, the only target you've got, for instance, on vehicles, right? It's your end of life vehicle legislation. And the targets we've got there, they all relate to the whole vehicle. There's nothing there to actually relate to the recovery of magnets or the recovery of motor even. So some of these things need to change, because when you start putting this sort of targets out there, then it instantly people will start thinking about, okay, how can I meet this target? How can I recover my magnets, etc. I agree with Francis also what she said about the primary supply. I think that's right. And I think we have to acknowledge that both companies at the moment, they're trying to scale up production in the recycling landscape. They are developing hydrometallurgy as well, which can be used also for primary supply. So it's not, it can have, it could feed in material from primary supply as well. But I think it's not though just about the recycling, is it? We have to think about all the other R's that exist in the circular economy as well. And this is where we need a lot of engagement, a lot of work with OEMs, just to think about design and design for disassembly, which is a really big thing at the moment. Unfortunately, it's not economically viable to recover these, magnets for motors, because it's just so difficult. Everything is glued together. So we need to find ways to get to that sort of technology transformation where these sort of things are viable. So I think that's another very important must do into the next 5-10 years.
Mm-hmm. Yeah, I think that sort of leads quite well into the next question around the priorities for research and innovation in the UK. So the roadmap sets out where we want to go, and a big part of getting there, I think, is research and innovation, as well as investment in other aspects and capital infrastructure and changing behaviours, etc. So where do we think that the best areas are for putting that resource into research and innovation? Can I come to you, Markus?
Yes, with pleasure, Matthew. I think there are two strands. The one is sort of the technological and chemistry angle. I think there's a massive amount of feedstock building up in the UK. You talked about the missing midstream. There's very promising research out there where you can recover materials in much higher efficiency. You can also segregate more metals, not only rare earths, but others as well. And I think while this works at lab scale, I think there is a benefit of demonstrator projects and moving this up the level of implementation. But also I think on what you can do with robotic disassembly, what can you do with sort of further refinements to repair. We work with the company Renewable Parts, so that they could easily repair if there would be permissions to remodel this with additive manufacturing. So I think there is a lot on the technical side. But I think there's also on the business side. The reason this is not happening is because value cannot be created and shared along the value chains. And when you see sort of successful circular economy models, it's typically where the OEM or some other orchestrator gets together the different parties and creates a mechanism for making the change. So Abby talked about everything is glued together, makes it virtually impossible at current costs to recover materials in the recycling. If you actually would have found a different technical solution, that cost could be achieved. But how would the designer be rewarded for this innovation? And there we think that potentially more research on the economics and also the regulation which could motivate this would be very, very helpful. For instance, sort of demand side levers. This is a very nascent industry. It's very unclear how the end game of this will look like. Therefore, it's very risky setup to invest right now. If there would be certainty on the energy transition, if there would be certainty sort of on putting some CO2 pricing into the market where sort of additional sources of value are being created where sort of these business people could tap into, I think that would be really relevant. And I think we touched on this with the agent-based modeling, but that would be for me a very clear second strand to think through the value creation and distribution opportunities that should go along with the technical innovation where the UK has leadership role. And I think also think through how to make this sort of a global hero, given sort of the headroom that you have today, would benefit a lot from these type of economic questions as well.
Yeah, I think that's something that we're seeing as well, that the UK has really good strengths in certain areas. So we want to support those and build on those to make us the world leaders in certain things. On that point about like regulation, I come to you, Bob. Do you have any points on that in terms of where some research is required to kind of scope out the impact of potential regulatory changes on this industry?
Yeah, I think there's quite an issue in the middle there of what you would want to achieve by regulation, in other words, by legislating and formally putting in place laws, and what you might think about achieving through governance models. And, Markus referred to this, what are the stakeholders themselves doing within their supply chains? So that one area I think that requires maybe quite a bit of thought going forward is the role of standards, for example. If we're dealing with secondary material resource, can we accredit that material resource at some point in its reprocessing to say this is accredited as good as the virgin rare earth? The rare earth powders here are accredited as good as the virgin rare earth powders that you would otherwise get on the market. So,
Yeah.
Can we try and create those points at which the supply loop almost is seen as being complete? That would be a great help. And I think, yeah, we've got to think in governance terms as well, I think, of how we drive quite a lot of the things that will be needed for a circular economy. So how do we handle problems of collection and reverse logistics? That could be done by regulation, but it could be done by different forms of industrial models. So to ensure, for example, that having invested in building a magnet, the industrial stakeholder regards that magnet as being one of the most valuable things that it has, within its asset portfolio, such that it would not want to do anything other than ensure that that asset got returned to productive use through remanufacturing at some point in its life.
Yeah, good point. Thanks, Bob. Rod, would you like to come in on that?
Well, just very quickly on the area of research and innovation, I think one way that's been helpful for me to think about prioritizing different activities is to think about three types of research objective. The first one is R&D that will help us produce more. So there's the produce more angle. There's, second of all, the waste less angle, which is the refurbish, reuse, remanufacture, recycle. So use more of, including and adding in improvements in manufacturing efficiency. So waste less of what we do produce more of. And then the third strand of R&D, I think of as the use less strand. So this is the material substitution that maybe makes greater use of cerium in rare earth magnets and less use of the more expensive, scarcer rare earths, neodymium, terbium, and dysprosium. And there are R&D challenges in all three of those categories, and I think most of those are similar to what we've been working on the last 10 years, and I think it illustrates the degree to which going from initial laboratory research to commercialization takes more than a decade, even with the best of efforts to accelerate the research, but we still can benefit from better separations of individual rares from one another, less energy intensive conversion from separated metals into or separated oxides into metals and alloys, There's certainly additional work to do on different magnet chemistry formulations. There are R&D challenges related to the manufacturing efficiency, reuse, recycling, and so on. I would caution against, or I wonder whether recycling ultimately is going to be relatively more important than the refurbishment and reuse, simply because over the life of a magnet chemistries are likely to evolve and change. And so taking a magnet from 15 or 20 years ago, taking it out, dusting it off and putting it back in a new application may not meet the requirements of the technologies designed around newer, more efficient magnets.
Yeah, really good points. Thanks for that. And yeah, it's a nice categorization of how to organize research efforts. I might have to borrow that if you don't mind. Before we move on to,
sorry, can I add something as well? I'm sorry to interrupt. I can't raise my hand somehow. Anyway, I just wanted to add to what Rod has said, that there's another aspect, and that's about the monitoring aspect, the monitoring what's happening in the supply chain. It's such a dynamic landscape and things are changing so quickly. And I think we've put a lot of effort in trying to understand the UK value chain and trying to quantify the different stocks and flows of rare earths within the UK economy. And we've seen great change from 2017. We're starting monitoring this sort of supply, and so it's up to here. And I think we need to continue this work because things are very dynamic. And if more, reverse supply actors appear, then things obviously will take a completely different turn. That's really, really important aspect as well. And we shouldn't underestimate the effort required as well to do that.
Yeah. Thanks, Abby. So quickly, just before moving on to the next panel discussion around lithium-ion battery materials, I thought I'd ask a quick question around the technologies that are used for recycling and the processing of rare earth elements, and whether there's any opportunities to invest in technologies that have applications across multiple material sets, so including lithium-ion batteries, but maybe some others as well. So I don't know if anyone on the panel has seen those kind of opportunities come up, where those technologies have that complementarity across different mineral sets. Anyone like to come in on this one? Maybe I'll go back to you, Francis.
Yes, I'm not sure. I always think that the technologies are, I'm not sure, I can't think of an immediate technology that will apply to both, but as soon as you come into the business models and some of the reuse and the clever things that you can put on before something goes to recycling. So that's something that we've written about with a case study of a company called Circonomics in Germany in the battery materials. So just to hop forward to the next panel discussion, where when the product arrives for recycling, so this could be a rare earth magnet motor of some kind, just the same as it could be a battery, then you actually check, find out, hopefully it will have a product passport, hey, very soon. That would be really at the top of my list of regulatory things. And then you have a wide set of clients, and maybe with a bit of AI and stuff, you sort out what it is and whether it's best that there is maybe there is somebody out there in the firmament who would like to reuse that magnet, or maybe it needs to go around short loop recycling, or maybe it needs to go around a longer loop back to the original materials, and you make some clever informed decision rather than just some haphazard thing that it arrives at this particular recycler and therefore it'll go through this particular process and on through that way. So I would have thought that technology is pretty transferable across anything in circular economy at that stage. So that would be my pick. Maybe somebody has something clever.
Well, I don't. Is the answer, but it's very interesting, I think, to look across technologies from a legal or regulatory point of view, because time and time again you see the same issues. So, if I just give you some of them, transparency about sourcing in the first place, what has gone into this and where has it come from? Labeling, in terms of what is now in it, and handbooks on maybe if I'm a dismantler, how I can access that. Design for disassembly. And very good and strong cost benefit analysis on the comparative advantages of some of the stuff that Rod's been talking about. What might I gain if I just refurb and reuse rather than simply assume that I'm going to recycle, and often recycle in a very crude way. So I think those are some of the advantages almost of looking across technologies, because you begin to build an agenda of things that we should all be working on, and not just actually in the metals area very often, but they are just symptomatic of those potential roadblocks that stand in the way of a circular economy.
And then quickly building on this, sort of, Evie mentioned, it's good to have sort of an observatory that is dynamic. And I think what Bob just mentioned, it's also good to have an exploratory. Sort of very much we have the dark side of the moon phenomenon. Yeah? Sort of a lot of things are very imaginable, but they're sort of not yet available at scale. And I think sort of being able to explore different configurations, because they have different lead time, they impact the buildup of stock quite differently. It's very important sort of to also dynamically model. I think that was done in the ABM, and having this available as a research tool across different commodities, because they are typically bounded in very few signature applications like vehicles, transportation device, computing device, machineries. That would go a long way, because you have a lot of the similar question at the ensemble, at the component level.
Yeah. Well, I'm conscious of time, so I think we'll have to wrap things up unless anybody has any final comments they want to make. If not, then I'd just like to say thanks very much to all the panelists for their contributions during the session. I think it was very insightful, so thank you very much. And I'll hand back to the webinar hosts for the next panel.
Thank you very much, Matthew. That was great. And so I could ask Chris for the next slide, please. Then we can go on. Right. So now I'm going to hand over the chair to Jeff, who had are you here? All right, Jeff had a bit of internet connection problems.
Yeah,
I can see you. Right. You made it. Wonderful. So our friend Jeff Townsend from the Critical Minerals Association, who are a project partner for Met4Tech, is going to take the reins now for our next panel discussion, which is on the lithium-ion battery materials roadmap. So over to you, Jeff.
Thank you, Francis. And it's been wonderful following Met4Tech since its inception, and the great work you've done. So we've loved that, the Critical Minerals Association. Where do you start? So I guess the names of everyone here you'll see on the screen. But I wanted to start with the first question, which is what was the hardest thing? What was the most challenging thing about developing these roadmaps, or this lithium-ion battery materials roadmap in particular? I'm going to throw to Francis and then see if we'll jump in.
Right. Okay. Well, I think trying to without a wonderful functioning crystal ball, Jeff, trying to sort out what the figures might be, because the even a linear economy doesn't exist. There's never mind a circular one, and so there are all kinds of things. The better we are at manufacturing batteries in the UK, the more materials we need, and maybe then the harder it is to satisfy those materials from domestic sources or recycling or whatever. And the worse we are, the easier it is. But that's, the more negative it goes, the better domestic supply could be at actually meeting the demand. But what is that, and how do you actually get figures that are robust enough to put into the public domain that people might actually use for policy? And there's that nice phrase, isn't there, about models? They're all wrong and some are useful. And so I think we've got various different sorts of modeling across Met4Tech, and we've tried to put together the results of those. And I think you can see some trends, and whether or not you believe the actual in detail the figures that come out. So that would be what I would say, is we really like to be quantitative as scientists, and it's really hard to foresee the future on the battery materials.
That's fair enough. I think, yeah, any future facing stuff is always going to be tricky, and it's always probably going to be wrong to some extent, but it's going to be significantly more right than anyone else because no one else has done it. So, that's a win to start with. Has anyone else find any challenges?
Yeah, I think picking up from that, Jeff, I think, it's a very dynamic environment. We've seen some really good efforts in the sort of UK and European context to try and establish some pieces of that jigsaw. But obviously, we've seen with British Vault and we've seen with North Vault, that's a non-trivial problem, and there are some roadblocks to even establishing significant chunks of that jigsaw. And I think, as Francis says, we haven't got all of the pieces of that jigsaw to properly carry out a full analysis. And also, it's sort of complexity is added by the fact that we're living in a very dynamic environment. I think over the course of this project, the relationship between the United Kingdom and the European Union has changed significantly, and the pendulum has swung one way and could well swing back the other way in the near future. I think, geopolitically, certainly in the past few months, we're seeing massive changes and potential realignments that mean that in many ways, some of the things that we might have considered stable when we were carrying out this analysis are all suddenly up for grabs, and the nature of national partnerships and alliances is changing dramatically in ways that could significantly affect our forecasts and changes. So I think it really influences the boundary conditions of such a study as to where you draw the sort of border of that circle. And obviously, these roadmaps and sort of similar initiatives have been developed with a view to try and shield the West, as it were, from Chinese dominance over the supply chain. But I think in the past few months, the nature of what constitutes the West and Western alliances is something that is, up for debate in the politest possible way.
Well, that's more diplomatic than I would be, so that's a good starting point.
If I could just add, so, I think Francis and Gavin have already made some really good points about the particularly turbulent times that we've had to do this job in and how hard it makes, I think there hasn't been, it's fair to say, a lot of appetite for innovative environmental, initiatives when even business as usual is under such threat, in the kind of economics of it. But actually one specific difficulty that we've faced with the road mapping, where we invite stakeholders to come and talk about how do we achieve that circular economy in lithium-ion batteries. And what we realized through this exercise, I think, is that we're not actually clear about some of the basics of that circular economy. So what do we mean, by recycling? What do we mean by reuse? What do we mean by refurbishing or repair? How do all of these differ from each other? What are the boundaries between them? And so what we realized in a lot of these, things that we were doing is that different people were meaning different things by these terms, depending on their own discipline or depending on their own background. So people might distinguish recycling and repair completely differently. And that makes it really impossible to formulate any clear policy to facilitate these things. That makes it really difficult to measure or monitor the circular economy activity that we're doing. And so we thought, well, we've got to do something about the fact that the definitions of these very basic terms aren't clear. And so we've, spent a fair bit of time on trying to develop a circularity-focused terminology, first of all, for achieving that circularity. So yeah, that's been a challenge.
Well, I think off the back of that, I just we've got two or three things that have just been said, and I want to unpack all three of those, but one by one, if I may. And so the first one is, due to what you were just talking about, it's more than just language, but language is still a key component of this, as it is with anything. The discourse between people is always different, and whilst you could be aiming in the same direction, sometimes you find yourself going in different directions. So what have you learned from interdisciplinary working across the NICER program? What have you learned in terms of trying to overcome those different expertise sectors collaborating on this project and making it work?
Yeah, if I could tell, right? So, okay, my job was to build a simulation model on like interacting with almost everyone from different areas. So the difference is that like each of us is doing research, but the scale and scope of the things actually change with the areas. Like how a chemist see about developing a new battery chemistry is very different from a business perspective. Or like actually some things are scale, like what we seen what we develop in a lab actually takes time to be made commercial. So there are conflicts of interest within the research groups itself actually regarding circular economy, particularly like I could see within the electric vehicle battery itself. So sometimes we need an alignment, actually really need an alignment. Some communication actually need to be little more better in this aspect. That's one thing which I could notice during our period of interaction.
Thank you, Krishna. Anyone else?
Can I add to that? I think overall it's been a fantastic experience. I think we've all learned from each other. We all have different vocabularies that we're using to say the same thing. And I think after 4 years, we are now in a position that we understand each other. And I'm looking at Jyoti because I know she's been trying to put this like our own terms of reference of the circular economy for technology metals, which has been really interesting because we all came from different angles and we had to have this really deep conversation about what do you mean recycling, and if you're a data person, what do you mean recycling, if you're, like a person in the lab that does, if you're a model, if you're a geologist. It was really interesting to see how different perspectives actually influence the way you think, but also the way you will define something. You need this sort of interdisciplinary system if you are to resolve complex problems like, what do you do with the lithium-ion battery when it comes to the end of life? It's really complex. You can do so many different things. You can give it a second life, a third life, you can get it to recycling, you can refurbish it. You need to have this sort of interdisciplinary things. You need to think about safety, you need to think about what the legislation is like, you have to think about social science, what the people maybe that they sit next to a recycling plant will think of. And I think it's a very important aspect in research, and it's something that should be encouraged more and more. It's very, very valuable.
Yeah, thank you. I completely agree. Well, that leads us on nicely then. So if that's the opportunity that everyone enjoyed and everyone started to learn from each other, let's go on to the other side, because of course this is industry focused. What are the roadblocks that exist in new technology metals, circular economy roadmaps? What are the roadblocks that exist, and what are the levers? What can we do to get around them, over them, through them? But what's the first thing? What are those roadblocks in building these roadmaps, or that you have identified within these roadmaps?
I think something that you'll be really conscious of, Jeff, with the CMA, is the fact that we're, as we sort of mentioned in that previous session, we're all talking from slightly different disciplinary perspectives, and we're growing together as a UK community. But also, it's very much a community that is evolving and growing at the same time, with a sort of changing constituency. And I think it links back to that, not quite having all of the parts in place, but new people starting to join that community and unite in the common effort. And I think there's a real challenge there to try and, bring all of the same people under the same tent. And that's an enormous communications challenge. And of course, the CMA also speaks to that role. But I think it's that trying to integrate the knowledge that we have from different domains of expertise, both in terms of different subjects, but also, from those different industrial groups within that context of change and evolution, is a real challenge.
Yeah, completely agree.
I think I could, hop in there. So we have one of the narratives is called Missing the Midstream, Jeff, which we know will chime with this week's all-party parliamentary group discussion as well. And I think it's lining up all those ducks in a row so that actually you can have the value chain, because it's no good if the lithium miners get going and then they end up selling their wares, whether it's lithium carbonate or lithium hydroxide, to somebody in China or something, because there's nobody who can take the next step in the UK. And likewise, if all the battery folks get going, but then they can't because they can't get the materials, then that's not going to work either. And I think that's the hardest point about business failure, is how do you get everybody to be able to move forward and get the investment they need at the right times to put the whole of that value chain, including obviously the recyclers who are, I see the technology improving really fast, and things that we already probably wrote in Met4Tech that, it's really hard to recycle lithium iron phosphate. And I noticed one of our partners putting out news in the last couple of weeks that they're ready to do that and could scale that up. So I think, it's just getting that all to sit together is a really hard challenge, and maybe that's where you need some government intervention. I think in the tech metals space, where the value chains won't completely make themselves, even if you have a lot of innovative startups all the way along, it's really hard for them to get joined up at the right time to make it all work.
It's one of those things. I remember when I first started lobbying the government, I said, if you want to build a new economy, you have to build all of it all at once, upstream, midstream, and downstream. You can't have demand led. All of it's got to be built all at the same time, which A, the government wasn't particularly happy with because it doesn't match any economic models. But B, when you've only got 80%, speaking to Gavin's point, when you've only got 80% of the data, where do you jump first? Because it might be a great big bloody cliff you're jumping off. So it's very tricky, and if you are risk adverse, it's very hard to do. But yeah, so I guess then what are the levers? What can be done? I mean, government intervention is one. Is it greater cooperation and facilitating greater cooperation at industrial level? Is it sharing information and making sure people are better informed?
I think particularly with lithium-ion batteries and with sort of us wanting to move to, electrification of transport, the complete newness of what we're trying to do means that we've got to ensure, before we start putting in policies and saying, well, we've got to phase this out by this date and whatever, you've got to make sure people buy into it, because none of this is going to work. Neither is the actual electrification of transport going to work, nor is the recycling going to work, unless people start to buy into this at scale now. There's such a lot of misinformation, about electric cars now. Everybody has an opinion that's kind of presented in a really half-baked and one side of the story way. People make their own thing out of it. So the lack of confidence amongst people, the lack of charging infrastructure, the lack of the cost, the lack of support really with the costs of EVs. It could become a complete non-starter unless people buy into it. And so I think that's something we really, going back to the point that I think Rod made earlier for the rare earths roadmap, we've got to begin with that. And I think perhaps we could do a little bit more, on that end, don't we?
I think, Jyoti, it's even going a step back. Before talking about specific elements, I think there is still a massive challenge in terms of raising ambition and having the ambition at the right scale. I mean, when you look at the absolutely phenomenal industrial transformation in China and the holistic long-term policy approach that has been taken, not only to developing those supply chains and the manufacturing, but also in things like creating the market conditions for that whole supply chain and manufacturing effort to thrive. I don't think in the West we've got anywhere near that level of ambition to have a sort of managed industrial strategy. And I think everyone within this call plays an important role in keep highlighting the need, the absolutely crucial and critical need to raise levels of ambition around the whole materials supply chain, and also the benefits that that can have for industrial development. And I think before we even get into the nuts and bolts of those jigsaw components of the supply chain, we really need to start from the perspective as, you know, as a society, what is it we want to do? What do we want to achieve? And at what level of scale and ambition? And I think while there's still hesitancy and a lack of clarity, we aren't going to make the strides that we need until we're fully committed. You know, there's a really sort of good, I think it's a Goethe misquote, but you know, whilst there's hesitancy, nothing quite gets done. But when everyone really girds their loins and galvanizes themselves to make something happen, then we can achieve the transformation. And I still think we're at the stage of needing to raise ambition to much higher levels to make sure that this transformation occurs.
Indeed, ambition and decisiveness, I think. And I think that's an inherent sort of, you know, perhaps advantage that China has, which we don't, is that decisions can be made, you know, without necessarily being too hampered by too many counter opinions. And maybe we need to kind of now make some decisions. We've done a lot of navel gazing about what we want to do, what we want to achieve. We've got to now just start doing it, I think.
Maybe I should put in a plug for the NICER program at this stage, Jeff. So it's something that we've done in Met4Tech, but certainly the CE Hub has worked very hard to put case studies online. And I think that's something in circular economy that's important, is to find where it's working really well for businesses, so that then people will be able to see that there's a model that works, and then maybe they'll be able to apply that from one product or material across to another. I think we've got Emma Schofield on the call this afternoon. I'm surprised she hasn't popped up and said platinum and group metals already. I know that they put out from Johnson Matthey some circular economy kind of roadmap publications recently showing how what they call their closed loop system works, where the chemical companies own the PGEs and then they go back to JM for reconditioning, and that's a very nice closed loop. And Rolls-Royce, of course, do that with some of their most key materials, and maybe there's other industries that could pick up from those kind of models. So seeing where other business models work and then transferring across and making that information available is something that we've been trying to do in our, you know, own way in the NICER program, and I think is really important for circular economy to do in, you know, in a bigger way going forward, so that people can learn from the things that work for businesses and can then have a go at that.
Okay. Again, so much more we could talk about than the time allows us. I know we're running short of time, so I'm going to cut it down to 2 more questions. So off the back of what you guys have just said, Abraham Lincoln, things may come to those who wait, but only the things left by those who don't take action. And I think that's very much what you said, Gavin, is if we're not going to take action, we're going to miss the boat. So, you know, with by foresight, by knowing where to go in the following the roadmaps, we have the ability to plan the direction we're going in, and hopefully the government will push towards action more than words, which would be great. What should manufacturers do in their actions around the circular economy?
Well, I think
yeah, if I could say, manufacturers actually should be ready to create an ecosystem. Like one of our partners, the recyclers, when we were talking about recycling of batteries, they're planning actually to build a factory near a manufacturer so that they could get a like manufacturing scrap, because from the recycling scrap is always uncertain. You cannot make sure that you have the exact quantity to run your expensive machine. So the manufacturers should take initiative, particularly the battery manufacturers, to club recyclers with them, so that like the manufacturing scrap reaches them, so that they can reach the economies of scale, and also they will so the ecosystem works very well. So that's one thing which they should do. Yeah, thank you.
I was
Yeah,
going
Gavin, please.
I think there's two things, Jeff. I think one thing that has been highlighted by work that's come out of the University of Leicester and the University of Birmingham is very much around this sort of design for recycle. So looking at the early stages of products before they even reach the shelves, what can we be doing to build batteries in a better way that makes them much easier to recycle down the line? And I think there's been good collaboration in this project, especially between Met4Tech and the Faraday Institution Relive project, to provide some practical solutions, you know, to aid in that effort. I think another key theme that I think is really important and cuts across a whole bunch of different things is trust. And I think, you know, from a perspective of manufacturers, if we look worldwide at various electric vehicle manufacturers at the moment, we can see how quickly the trust that people have in electric vehicle brands can be destroyed. And I think, you know, it's really important, if we're to maintain momentum, that we have brands and we also have, you know, alliances that we are able to place trust in. And I think especially from a material circularity perspective, action is really important. You know, we need to take aggressive action in order to develop a sort of Western response to ensuring the robustness of critical material supply chains. But I think we also need to temper that aggressive action and ensure it's done in a way that, you know, countries and nations are brought alongside together in a diplomatic way. And I think there are risks of destroying trust between various alliances if that's not done in the right way. And that has manifold impacts for the circular economy.
Yeah, it does.
And I guess to add one more thing that manufacturers, in addition to designing for recycling, could do is also to kind of maybe invest a little more effort into extending the life of products, making them more repairable, making them, you know, designed to last a bit longer. That would be hugely helpful to a circular economy for LIBS.
Yeah, I think that's a nice point, Jyoti, and that reminds me, I think there's a highlight topic that talks about the design for longer life versus recycling. So manufacturers have to be clever, don't they? Because we want them to make their products that last longer, but then we want them to be easier to recycle or remanufacture some of the components when they come to that stage too. So they mustn't put them together in a way that can never be taken apart. So it's kind of a double challenge, isn't it? But I think my one, Jeff, just to say quickly, is maybe it comes back to Gavin's trust bit a little bit, is about the product passport. I remember years ago, before we even did Met4Tech, listening to RS Bruce talking about the batteries arrive with them and they know nothing about them, and just seems so, you know, obvious. And countries are now passing legislation that requires some kind of digital product passport, and that has to be obviously a very international operation with organizations like the Global Battery Alliance trying to make passports that would be suitable for those kind of regulations. And so I think if manufacturers could cooperate, so it can move faster than legislation will come through and ask for it, that's still years away. So just cooperating with things like that Global Battery Alliance initiative and other ones that are similar, so that when recyclers get the batteries, they at least have the basic information about what's in there. It seems really obvious to us outside of the industry, if you like, and I think that would be really, really useful first thing that people could do.
But from industry, it's obvious that we don't want to tell everybody what's in our batteries, so don't want to put that information on a passport. Thank you.
Yes, but maybe, well, this is when I talk about the trust, Emma. That's a great point. But maybe there's, you know, the Global Battery Alliance are trying to sort out. There's some basic information, so it needs the conversation, doesn't it, between the folks who need to do something with the battery and the folks who are making the battery to work out how you can have a safe platform, and there are initiatives around this, aren't there, so that when it comes to the end of life, you can, whether it's reading a QR code to get the very basics, or whether it's dialing into a secure platform, blockchain secured or something, where it's coming along, and because you're an official recycler with all the right passes and everything, you can get in to find out what it is. So there we are. That's probably needs some more RD&I, but I know that various people have been thinking about this, and I stand by my asking manufacturers to do it, Emma, though you make a very good point, of course.
Well, we're over time now, so I'm going to ask one last question, and then I'm going to hand over to Bob Lee to take over from me. But my final question is, based on what you just said, Francis, and Emma, your interjection, is how are the two roadmaps different or similar? And would another mineral metal material be a similar roadmap as well? Is there ability to replicate this across multiple different chains?
I'll start with a very short answer, and then maybe others will come in with something more considered. I think now we've done a couple of roadmaps, we'd be faster doing a third and a fourth and a fifth. I noticed the PGE one. It'd be really nice to have a look at that in this light as well. We really want one for tin and for tungsten that the UK is ramping up and to start mining again. So it'd be really good to have a look at those. I think they do have some similarities in looking at the higher value loops and whether or not we're recycling and the primary supply. But having said that, you do need a different one for each different material, and maybe I could use the platinum group as an example. It's so much more valuable, so much more expensive to buy PGEs that people take more care of them and they don't chuck them out, whereas the 0.07 grams of neodymium in your mobile phone is not a big incentive to looking after that in the same way. So I think each material will be different, but we certainly have seen some things. And if you when you're looking at the roadmap, if you compare them, you'll see some very similar things about the lack of the higher value circular economy interventions like remanufacturing, and how some research to put that in place would be really useful. That would be common across the two, those kind of things.
Perfect. Okay, well, I'll leave it there. Thank you ever so much to everyone on the panel. I think some really good points made, lots that we could have carried on speaking about. But with that, Q&A, and let everyone else talk. So I'll hand over to Bob to take over from me.
Thank you, Jeff. Forgive me, everyone. I've got a bit of a cold, so I've got a bit of frog in my throat. I did notice that Chris Yeomans, who's on the call, put a few comments and a question in the chat. So I'm wondering if I could ask Chris just to unmute and ask him to offer any comments he might have.
Hello. Was it the most recent one, Bob, you were?
Yeah, the most recent one was a question, but I didn't want to restrict it to that if you had other things that you could contribute.
I'll keep it brief and just kind of my slightly cynical question was along the lines of I think it got discussed quite well in broad terms of action is required to address the competition of Chinese dominance in the market. But one of the things that I haven't quite grasped is, firstly, how do we get a united view on an industrial strategy, and can we compete at the scale China is currently operating, even if we did manage to get consensus across, say, the European market or even the entire Western market? Because as I think Jeff said, when he was advising government, they need to be building upstream, midstream and downstream for a new economic model, but that requires a vast amount of capital that China managed to generate through various means to then capitalize and take even further, so they dominate the global economy. How do we fight back, essentially? Because ultimately, if they decide to flood the market with a particular metal, us open free market countries find it very difficult to respond without a managed industrial strategy.
Yeah, thank you. I mean, those are really good points. I think there are certain things that you can achieve in a highly centralized socialist economy that you probably just can't achieve anywhere else in a liberal democracy. And that is a simple fact. I think if you look at rare earths are an example of this, if you look at how rapidly and easily China has managed to consolidate its rare earth supply, and by so doing, in effect, somewhat control the export market, is quite astonishing. And that's really important because it feeds into lots of the things that we've been talking about. It feeds into all of Rod's point about price signals. Excuse me. When we're seeing those price signals, they're not true market signals necessarily. And that means it places countries that are dependent on that rare earth supply in a very difficult position. Because, for example, in relation to magnets, you will find it cheaper to purchase a sintered magnet from China than you will the rare earth materials that actually go into that magnet if you wanted yourself to start from scratch. So it's a really, really difficult issue. It is, of course, I would just add, an issue that is not being made any easier by the present dismantling of world trade law and notions of sort of equitable access and sharing of benefits.
Perhaps a slightly another cynical comment from me. I'm trying to make them all cynical, but perhaps in some respects, the only way to take control back of our supply chains is through some fairly aggressive tariffs or other policies that fit in. I'm not saying I necessarily agree with Mr. Trump's rhetoric, but how else can a Western economy challenge such a dominant power at the scale that, you know, it's got over 1 billion people united in the same effort? The West just can't compete with that level of productivity.
And I think, and again, that's really relevant, isn't it? I mean, you see people talking about Keir Starmer and what Starmer might do by way of response to Trump, but he's painted absolutely in the corner. He knows that if he does retaliate with tariffs, it's not going to make the global economic situation better. It's going to make the global economic situation worse. On the other hand, if he doesn't, he's left looking much less than robust. And we have seen, and you've seen in Europe, the slow relaxation. It has been rather slow, but the slow relaxation of historic state aid rules and the slow unwinding of that to allow more investment in these markets. But it's you're right, Chris. I mean, it's too little, too late. I'm going to hand over to Francis, who's got a hand up. Desperate to go in.
Just to say, yes, so we can't be China, can we? And we're not trying to displace China altogether, but we can pick our battles, hey? I would say it's pick your battles and then go deep. And you have to have deep pockets. So somebody has to be prepared to prop up companies when they're not going so well. There was controversy last week when the European Union named Northvolt as one of the 47 projects in the EU, because obviously they're in liquidation or whatever one calls it in Sweden. But I think that's the right thing to do, because maybe it's a point of business failure that these value chains won't make themselves, and maybe exactly what they need is for someone to flag them as one of the key projects across Europe and to help them get some more investment. I know there's always a problem about failing projects. You don't want to prop up projects that will fail anyway, but maybe governments need to take the risk that they might do that for a few projects in order to get the other ones going. So I would say pick your battles, and maybe that's a conversation for another day, exactly what the battles would be. But I think we've seen the UK step up with things like the climates programme. So it's already been nominated that rare earths are one of the battle, and obviously the lithium-ion batteries are definitely another battle because of our car industry, and I think helping to support that and all the jobs across the UK that it provides. So I hope that the Met4Tech roadmaps, Bob, will provide some useful insights into if those are the battles that the UK is gonna see, what we can add and how we can really get those industry value chains going. That would be great.
And maybe just one reflection on what has China done sort of in the 80s, so that they started observing the market, and they were sort of going through certain sort of what if type of trade-offs, looking at the science. And I think that's exactly sort of the observatory and exploratory work that sort of was part of the Met4Tech, sort of is a prerequisite for informing this type of decision making, because the capabilities that are present are huge. And I think that there's questions of how to form consensus around this to make these educated bets, because I think they are essential, not only sort of to compete with China, but to make circular economy a reality, which sort of is inevitable. Sort of the linear economy will not allow us to perform at this level of joint ambition that we have formulated. So I think having observation and exploration are distinctive capabilities that would require further research.
Any last questions before I close the session? I'm not seeing any hands raised scrolling through. Well, I would just like to say thank you very much. In particular, I'd like to say thank you to Francis, actually, for her leadership as principal investigator on this program. I hope to speak for everyone on the research team when I say it's been a great pleasure, actually, and it's been a great interdisciplinary project, and I hope we've made a good job of the roadmaps. But I think as researchers, we've all learned a great deal, often that went well beyond our core sort of set of expertise in the process of engaging with exercises such as the road mapping. So thank you, Francis, for all of that. And thank you for all of the support that we've had from Carol, from Chris, from Sam and Navia and all of the other support teams. Most grateful. I come to the project in one sense with a heavy heart now that it's ending, but I think many of the researchers on Met4Tech are moving on to other research projects in similar areas, and we do so with much gratitude, actually, and I think with much benefit from the work we've done in Met4Tech. So thank you very much.
Thank you, and thank you to all the project partners on that slide. And should just say, do please go and read the roadmaps and feedback to us about them, and so we can do the final versions and get them up there on the Met4Tech website. So, well, thank you very much for that. And as Carol says in the chat there, thank you very much for everybody for participating this afternoon. Do go and have a look and give us your feedback, and onwards to the next steps in our circular economy research. Thank you very much, everybody. Goodbye.
Thank you very much. Bye.
Bye.